This is the builder's perspective course, so I'm going to kind of drive this one. Jennifer and we always do these together. This happens to be one where I'm going to speak a little bit more. I would rather listen to Jennifer speak than myself, but I'm in the driver's seat today. So
Yes,
um,
today I get to be the make the jokes and the
yeah,
wisecracks and stuff.
keep things light. Um, Quick today's learning objectives. These are just formalities. Understand the drivers for ZNE. Learn the roles of heat pumps and some ideas and tips for selection of all electric equipment, heating, cooling, space conditioning, hot water. We will talk a little bit about whole house ventilation. It's all part of the package. Um, Tips for working with your clients. I'm in the direct line of fire with clients as to navigating conversations about zero energy and getting their homes to zero energy. So we've got a few little tips on how to work through those conversations, and then we'll wrap it up with best practices for renewables and battery storage. This is the agenda that we're going to follow. Quick overarching strategy for zero net energy. We're going to work through building enclosures and air sealing. We'll talk about heat pumps, some fresh air ventilation, whole house ventilation. Whole house ventilation in terms of zero energy, not a typical giant whole house fan with a leaking crawl space in the house. We'll talk about appliances, and we'll talk about PVs and battery storage. We'll try to stick to that agenda. So Jennifer owns Inbalance Green Consulting. Quick little intro for us. Jennifer and Andy Pease co-own Inbalance Green Consulting here in San Luis. She's a licensed architect in California, certified energy analyst, and one of my favorite nerds to talk about this kind of stuff with. She's also a pretty skilled builder herself, has been in the field and put things together for a lot of her life, and comes from a family of people who did such as well. I'm Mike Horgan. I'm a licensed builder in California. I used to be licensed in Massachusetts and California. I don't plan on building in snow again, so I let my Massachusetts license run. Been a licensed builder for 22 years now. I'm a FIAS certified passive house designer and builder. I've done FIAS certification and I'm a PHI certified. I've done PHI and FIAS, which is the US based one. There's a few small distinguishments between the two and a bad divorce that happened years ago, but we're all trying to get to the same goal. So um, since this is my perspective, and I tend to be in the field a lot, and I've been in the field most of my life. I think part of what we're trying to do is help bridge the conversation between architects and designers and people in the field. Um, Jennifer is going to be monitoring the chat during this whole process. I do not know who's in this workshop. I try not to pay attention to it, so we try to speak as if it's people who've never been here before. So some of the stuff we're going to repeat. This is actually, I think this month is the 5-year mark of Jennifer and I doing these workshops together, which is kind of wild. Um, she'll monitor the chat. Any questions that you have, you can put them in the chat, and if she feels it's appropriate to stop in that moment, we will. But the goal of this perspective is to give you an idea of what it's like in the field, trying to build a zero energy home, and how to bridge maybe some of the language gap. Uh, this is just my perspective. It's what works for us. I've had the great fortune of making lots of mistakes and probably losing a bunch of money, super early on when I was young and dumb and didn't really care about that kind of stuff. And then got to refine it all through the years. So uh, builders have the control of driving down the loads in the field. The actual stuff we put together with our hands is reduce, reuse, recycle. We're trying to reduce the loads by the work that we're doing on the homes and in the field. And through that process, what we're going to talk about are strategies to help builders make that simpler, which architects can communicate to them, and try to keep the whole process easier and cost effective. There's no reason that these things should balloon in cost. A lot of the strategies we're going to talk about, if you're familiar with Passive House, I know there's a lot of people becoming certified the last couple of years, which is fantastic. An unfortunate effect of the fires that have been happening is that Passive House went a little bit viral in the world, and we've seen a great uptick in people reaching out for Passive House homes and to become certified because, lo and behold, even though it was invented as an energy reduction option, it turns out there are a lot of outlying benefits to it as well, and one of those is fire resistance. So the strategies we're going to talk about today, we're largely going to focus on envelope assemblies, windows, and balanced ventilation, but we are also going to talk about all electric appliances, PVs, and battery storage. We're assuming that we are all, if we're in these workshops, moving away from fossil fuels and trying to build homes without fossil fuels. So the goal is to kind of take you through how we build a house. And we're going to start from the bottom and work our way up. One of my favorite slides that I've ever put together is this slide. So we still hear today, well, I hear building an energy efficient home is a lot more expensive, 10 to 20% more expensive. Like, what are we talking about for costs? Well, what we're really focused on here are our air control layers, which double as our WRB, our bulk water control layers, and our thermal control layers, our insulation layers. And this is an actual pie chart we do a pie chart like this for every project that we do because we're nerds and we like to figure this stuff out. And we like to show people that what we're talking about is some of the lowest hanging fruit in all of the course of putting a home together. And it's also the lowest hanging fruit in terms of budgets for projects. We are talking about very simple things, a lot of them that can be bought off the shelf, that are not your big ticket items. We do talk about windows, and they're a big ticket item, but they're a big ticket item in every project. This little sliver for our air and WRB layer is so small you can't even fit the percentage point into the slide. That's the stuff we're talking about doing a little bit better as we work towards a Z&E home. So since we're going to start from the ground up, and please ask questions about anything, materials, costs, put them in the chat, and Jennifer will give me a nod and stop if we need to answer some questions. So almost all of the photos that are in this workshop are photos from projects that we have built or are actively building right now. So I'll be pretty intimately familiar with everything. So we're starting at the bottom, and we're using an air layer and a vapor layer, a control layer under our slabs or in our crawl spaces. So a Stego
No.
15, sorry. So a Stego 15 mil vapor barrier directly over your aggregate. And in one of these photos, you can see both of these photos. We use an aggregate. We have used an aggregate in a couple projects. It's actually an insulating aggregate. It's a recycled glass called Glavel. I think there are 2 or 3 different versions of that available in the US now. It does provide an insulation value of, I think it's 1.5 per inch. Someone can double check me on that. It's been a couple of years since we've done a big Glavel project, but we do have one coming up. So we're actually getting an insulation layer underneath our vapor barrier, and we're sealing that vapor barrier at all edges. So this is the mastic that we apply over grade beams to ensure that that seals down over the grade beams. And we apply that same mastic around the slab edges before we pour what's called a cold joint slab. In the next photo, this is a crawl space application, and we're actually switching some of our builds away from slabs and going to a crawl space raised floor system. And this is actually the system we use. This is not our project, but this is mimicking the same exact system. So we'd be forming our stem walls on the outside perimeters, and then we would have a dirt crawl space or an insulation crawl space. Maybe there's an R10 insulation over your dirt, and then a stego vapor barrier over that insulation layer. And again, sealed at the edges where it goes up the stem walls of your footings. I'm going to try to go quickly so we leave lots of room for questions at the end and kind of a conversation format. Pretty open source, open book about everything. So hopefully I don't go too fast. Jennifer and I tend to talk a lot about this kind of stuff. So um,
Well, why wouldn't we?
I
It's
know.
super fun.
I mean, I
I
think there's, I
think
think we
it's
got a
fun.
lot of, we got a lot of people attending this one, so that's kind of cool. That's more than usual. So real quick, we've gone underground. We're coming out of the ground now, and maybe you have a slab, maybe you have a raised floor over a crawl space. But either way, as we begin our framing, or as your framers begin your framing, or for architects, as you're instructing your builders how to begin the framing, one of the most important things that we do on our projects is we begin to seal our sill plates to the concrete. So we're going to stop that airflow. We're not using a foam sill. I don't even know what the brand name is of it anymore because we haven't used it in probably 15 years. Because all you're doing with those little foam sill plates, you're just filtering the air that's moving through. You're not letting as much dust through, but the air is still going through. So we want a true seal. So we use an acrylic membrane, and there are a couple different methods of doing this. Um, in one instance, we hang our sheet goods, whether it's CDX or OSB, um, onto the walls. And right underneath that, where it meets the concrete, we run a bead of caulking. Um, we use a brand called Contega. It's an elastomeric caulking, so it never hardens up. It always stays a little bit squishy throughout its lifetime. And we press that into the edge of the concrete. And as we start to run our WRB, we use a self-adhered membrane. We've also used stapled membranes. Our bottom edge of that membrane is getting pressed into this caulking. And just by doing that one simple step, we've now, we're continuing our bulk waterproofing off of our walls to stay outside the house. And we're also beginning the process of air sealing our entire wall and roof system, just with that little small bead of green caulking there. Another way that we do it is a self-adhered tape that adheres to concrete. We've done this a couple times. I find the concrete around here can be kind of dusty, so you really have to do a good job of cleaning off that concrete to make sure that your substrate is not covered with a powder, and giving that tape the opportunity to adhere directly to the concrete. There are specific brands that you have to buy that adhere to sheet goods, OSB, CDX, and simultaneously will adhere to concrete. This is a project we've recently completed, which probably a few people in here have toured. That's over off of Foothill in San Luis Obispo. It's a passive house, 1,000 square foot ADU, 3-bedroom, 2-bath that we've just completed. But that was the sealing system we used on this project. The importance of this, if you are an architect working with builders, or if you're a builder and you're subcontracting your frames out, uh, rough framing is called rough framing for a reason. Uh, Even the best framers are pretty rough around the edges, and when you've got penetrations coming up through your slab or coming up through your crawl space, uh, we tend to just hog out the holes in our sill plates in order to accommodate these vent stacks or drain lines that are coming through the floors. We're not super clean about it. Oftentimes you won't even see a hole saw come out. You'll just see a circular saw rip a big square out of the sill plate. And what that does is it leaves on the exterior edge of the wall, it can leave a gap in the sill plate of 3 or 4 inches. And if you don't seal that outside WRB to the concrete below your sill plate, you've got a 4 inch long, 1 inch size hole in your sill plate that's just going to let all the air flow into the house. So it's a really simple detail, and it's something that we do in practice almost every day on job sites, but the detail can get missed. There's nothing wrong with hogging out the holes in the sill plates. You just have to make sure you account for it by the WRB system in the air control layer that you're using, which you're supposed to do anyway, but it often doesn't get checked. And then the other picture is kind of a band-aid remedy. That's not one of our projects. I mean, we do use foam to seal big holes too. We'll use anything that's available oftentimes at a moment's notice, but um, a go-to for sealing big holes like that is usually a foam sealant. So if you're not gonna go with the keep it simple, stupid practice of adhering a membrane to the concrete below your sheathing, the backup to solve that problem is Kansas spray foam, which you can buy at Miners. So
Oh, Mike, can we go back to that picture? Do you remember, like, I think it was like 5 years ago? Maybe it was 6 years ago? I don't know. It was a while ago. Do you remember one time at the job site, you were proving to me how well the membrane sticks, and you had me go outside the wall and you grabbed a leaf blower and you started, and then you went outside and you did the leaf blower right on it. And
yeah,
it was super cool to see that it really was like physical proof that
yeah,
it was staying put in place. It was fun.
we had
That was fun for us.
a big chunk of a sill plate was cut out, and we piled up sawdust on the inside of the sill plate. And then I
That's
took
right.
a leaf blower to the exterior and put it right up against the hole in the sill plate that did have the WRB covering it to show how airtight our air control layer is, which is an air control layer is something that every builder has to put on every project. It's required. But using the right one and paying attention to the details, you get a true effect. So we stuck a leaf blower 5.5 inches away from a pile of sawdust, and no dust moved on the inside of the house. So there's a video of that out there on the interweb somewhere. Um, One thing we're starting to see a lot in projects now is if you're subcontracting your insulation, which sometimes we do and oftentimes we don't. Um, if it's spray foam, we'll subcontract it, but oftentimes we do our own bat insulation installs. We've actually done our own cellulose installs as well. It's difficult to find a cellulose installer around here, but we've noticed that insulation companies are now including interior air sealing just as part of their package. It's a box that you check when you get a proposal. I don't even remember what the fee for it is. It's a few $100s. And usually within the first hour or two of them arriving at a job site, they'll have 2 or 3 guys just load up caulking guns, and they'll go around all of the interior sill plates and caulk the interior sill plates, caulk the corners. They'll even caulk the top plates. And it's a quick and dirty method. And I'm not saying it's the best method, but I think it's interesting to note that even insulation companies are now including that as part of their packages just when they arrive to a house. So that photo on the left is even though we had air sealed on the outside and we had actually ticked the box to not have them do any of the air sealing on the inside, they showed up and did it anyway. Before you could even stop them, they were already in action. So just a little bonus. But we're seeing that as a regular practice on job sites now. And then the photo on the right is um, this is an air sealing detail we did on a large remodel. And I think 65% of the construction in California that's going to happen over the next 5 to 10 years is going to be residential remodels versus new construction. Although the recent fires are probably going to change that ratio a little bit in Altadena and the Palisades as 15,000 homes get rebuilt soon. Um, but as you're remodeling, air sealing from the interior is a really important task to undertake as well. And there's lots of different methods of it. Again, this is just one that we use. I find fabric first to be a good method to follow. So in this particular case, we took all the drywall off of the exterior envelope walls of an existing house off of Foothill, and then we air sealed from the inside. So rather than remove all of the stucco from the house and the disaster zone that that would make a project and make a neighborhood, we left the stucco on the exterior walls, removed the sheet goods from the inside, insulated and air sealed with this Intello fabric, which is a vapor open but airtight um, fabric installation. Just staple it to the walls and tape the seams. We get asked a lot of questions about windows that we're using and how we air seal windows, and we use flanged windows. We use flanged windows, which is a pretty common practice for most American construction sites. But we also often use flangeless windows, um, where you don't have a nail flange to attach the windows from the exterior of the house. So these particular window systems that are in these photos here, they're actually inset windows and they bolt, they screw to the rough framing on the inside. And what we're trying to show is that the air sealing system and the waterproofing system on a flangeless window isn't all that unusual for American construction crews to undertake. It's quite literally just tape, sticky tape wrapped around the openings and pressed onto the window frames. And a lot of the tapes you use nowadays, you have to heat activate them, and you do that just by taking like a little credit card sized so they call it a press fix. It's basically like a little credit card size squeegee, and just a quick swipe creates enough friction for the glue to activate, and it seals to the membrane that you're using and to the window systems that you're using. Most of those glues adhere to plywood, glue, fiberglass, aluminum, cement. Um, so we're using a lot of flangeless windows, really good, high quality. They often call them European windows. They don't need to be European windows anymore. Lots of good American companies making them. Lots of companies in Canada. Uh, these, the two on the left are Cascadias, and the one on the right, that's an Alpine window. So, um, window placements a huge deal. I feel like a lot of architects here are starting to take that into account. I think there's still some big Starchitect projects happening. You know, those some of the big 10,000, 12,000 square foot homes are still just giant walls of glass facing the ocean. And why wouldn't they be? But that gives you the opportunity to introduce and use some pretty incredible glass values if you're not going to have any kind of shading. But we try to take into account that building shading into your structures, your assemblies, designing them in is a pretty cost effective way to keep your projects from overheating in our warm areas. Uh, temperatures here are they're not going down anytime soon. They're never going to go down really. And even in St. Louis, which I think is generally thought of as a cooler area, is pushing well above 100 degrees for long stretches in the summer. Even Morro Bay is too in the summertime. Um, the flangeless windows that we tend to use, they don't all have to be tilt and turn. I know there can be some pushback from clients who are not used to having windows that tilt into the home or then swing into the home in a casement style that swings inside. Um, but all of the brands that we get windows from these days is generally two or three that are considered European windows. They do make systems that are typical to American clients, where you'll see outswing casements and outswing awnings, and you're getting the same performance. The difference is that we're pushing towards casements and awnings versus double hungs. And actually, we push towards fixed windows if we can, and having just a few operating windows. We're getting full seals on all four sides of the glass. That's the main thing that we're going for, so that air isn't leaking. We're using thermally broken windows as well. So all of our frames are thermally broken that we put in our projects, and the manufacturers who buy them only make thermally broken frames, so that our window frames are not acting as radiators. So if the outside temperature is 100 degrees and you've got west facing windows and the outside surface of that window is 126 degrees, the inside surface of that window maintains a cool, 68 to 71, 72 degrees, depending on the temperature inside the house. So all of our windows, whether they operate in a European tilt and turn style or they operate in a casement or an awning style like typical American windows, are all thermally broken windows as well. So we've moved from the ground up the wall assembly. Um, Talked about air sealing the walls, sill plates, the windows, the kinds of windows that we're using, and now we're moving to kind of a wild west aspect of the homes. And I know even in the passive house world, which I've been in for about 15 years, probably, um, this is still an oft talked about and discussed section, the wall to roof assembly junction, and it's something that we play with almost on every project. And actually, we've got one project that's almost done permitting that we've been designing for a year. And just last night, I thought, oh crap, I think I want to change. I'm going to change the roof, the wall junction for our air sealing. So we got to redo our detail for that. Um, there are a million ways to do it. We have done the photo on the left. We taped individually around every outlooker that was on the house, which sounds like a lot of work, but we had a framing crew helping us on this project, and they put one guy on it, and he was done in 2 hours. And it was a big house. It was a 3,400 square foot house, so um, 2 hours to air seal every outlooker, which that's a big component of homes here. We often frame with trusses, and our gable end trusses have a double top cord so that we can run outlookers past that. And then that outlooker often doesn't get air sealed, and you end up with a 1/4 inch gap on either side of the outlookers, uh, which could be fixed with tape. It could be fixed with caulking. You could use some of that same sealant we use on our concrete slabs and just load up some caulking guns and have an air sealing party for an hour on a Monday morning before everybody gets started. Um, anyway, a couple different methods of doing it. It's just a really important junction to pay attention to. We have overlapped our roof membranes and brought them right down our walls, and then we've had to tape the outlookers as they're popping through the membrane. I'm always looking for a simpler, more effective way to do it, and I'm trying to not rely on closed cell spray foam at that junction on the inside and count that as my air barrier. Um, Although sometimes you do the best you can with what you have. I think that's what we're all trying to do, and that does become the situation. Most of California is moving towards CEI, continuous exterior insulation, on projects. Uh, it's an incredible bang for buck in terms of energy performance, and reducing that energy load of the homes. And that's kind of the goal of this workshop, is showing how to reduce the loads from the builder's perspective in the field. Exterior insulation is not a hard thing to do. Um, Around the world, it's an everyday practice. It's still got a lot of pushback around here, and I can understand why. I think it has a lot to do with a fear of the assembly failing and the builders being held liable for those failures in an area that's already a pretty litigious area for builders. We're not licensed by a construction supervisors agency or anything. We're licensed by a consumer protection agency. So uh, when I put my builder shoes on and not my save the world zero energy shoes on, I understand why a lot of people are slow to move towards different assemblies and have pushback against changing their methods, because they find something that's tried and true and they've started to make a profit. And um, anybody who comes along and kicks the hornet's nest is probably going to get pushback. So I understand that exterior insulation is a touchy subject around here, but it's being done around the rest of the country pretty regularly, and lots of people are coming up with new, cooler, simpler ways of waterproofing and ensuring long-term duration of these kinds of projects. One way you can do that really simply is to use vapor open exterior installations. We don't use rigid foam boards on any of our exterior installation projects. We use a wood fiber board, or we use rock wool, the comfort board. Both are fairly dense boards, and they're fairly easy to install, and then fairly easy to install your exterior finishes over the homes. Um, Gives you the opportunity to install a rain screen, which is just one more aspect of keeping the energy load of the home low, because you've got your exterior finish that's absorbing all of the heat and the cool from our hot days here, and then our cooler, warmer, much wetter nights, especially as you move up the coastline and away from, say, AG or San Luis, and you move towards Morro Bay and Los Osos, where we can start building again now, hurrah, and then Cambria and Cayucos as well. Um, but we're really pushing towards these vapor open continuous exterior insulation assemblies. So Gutex is one wood fiber product. Styco is a wood fiber product. There's a company in Maine called Timberbat, which is making a wood fiber exterior board. Um, I think the Timberbat one is going to achieve a WUI rating. I know that Rockwool already does. So when we're building in high fire hazard zones, we're using Rockwool as our exterior insulation rather than a wood fiber board. But we're not using foam, because foam is an impermeable material, and vapor can get trapped behind it and ruin your assemblies. So we kind of covered the ground, the windows, roof to wall connection, exterior insulation fairly quickly. Hopefully this is all going to lead to questions and conversations. It looks like the chat board's lighting up, but I don't know what any of the questions are yet, so I'll just wait. So now we're gonna veer off into the mechanical aspects of what we're doing to some of our projects for our ZNE homes, and all of our homes are passive house goal oriented. Not all of them go through certification. A lot of them don't go through certification, but all of them are zero energy, fossil fuel free homes that we're building now, and we're using a lot of the same components. So we use only heat pumps for heating and air conditioning. Um, I think you'd be hard pressed to find anybody around here who wouldn't welcome air conditioning in their homes nowadays. I know 20 years ago you probably didn't need it, but St. Louis summers now, I can't imagine not wanting it. I live in Morro Bay, and I don't have air conditioning in my house, and I would kill for air conditioning in my house in late July, August, and September. Even I'm a block from the ocean and still gets super hot. So, few different systems that we use. There's a little pushback against wall-mounted ductless systems here. I'm not too sure why. So we often find ourselves using ductless ceiling systems that are made to fit in between 16 on center framing, which is our typical framing dimension here in the States. This is a project on the left that we helped do. This is our project. Oh, that's me. Our project on the right. The way we try to ease the minds of our clients when we start to talk about this new heating and air conditioning object that they've never seen before is we actually make a mock-up. That middle photo shows a plywood mock-up of the actual size of the unit that's going to be in their ceiling, and we'll bring them into the house and just hold it up to the ceiling and show them, okay, this is about what we're talking about. This is about the size of what we're talking about. It's probably going to stick below the ceiling about 1 inch. Do you like this? Do you like this layout? And we'll actually walk them through the homes and help decide where they want to put that, so it eases their minds about what they might perceive as an obtrusive object that could be in their home. And then these are our wall mounted systems. So some people are averse to these, other people don't care at all. We've been using wall mounted systems. I think it was 2007 we put our first one in, and I've told the story before about how I didn't even know what it was, and we were doing a remodel, and I couldn't get any ductwork up to a project. This was on Cape Cod. I couldn't get any ductwork up to a project, second story remodel that we had done. And our heating and air conditioning guy said, "Well, why don't we put a mini split in?" And I didn't even really know what a mini split was. And so I met PJ at 8 o'clock on a Friday. And by 10:30, he walked around from the back of the house and was loading up his tools again and all set. And I couldn't believe that in 2.5 hours, we'd had installed the heating and air conditioning system for a second story project that we did. So um, anything in my mind as a builder that clicks to, oh, that was simple. We're going to move towards simple because we've already got a million things that are trying to make our lives complicated in the field. So anything in terms of assemblies and mechanicals that I find to be a simpler, fewer problems, fewer potential for problems situation. That's the stuff that I like to steer other builders towards. It's going to make our lives easier.
Mike, can I add something?
Of
Just on
course.
the new construction, then you have the opportunity to put that refrigerant line like in the wall assembly, and then the insulate, you do your blown in insulation typically, and it's completely covered in there. And so it's just a sequencing difference on new construction compared to when we're doing all the remodel work. You end up seeing that refrigerant line, usually covered, but you have to create a cover for it. So it's more obvious. But new construction, the outside of the house, it's just super clean. And it's a
Yeah,
sequencing thing. And then you
really
just
slim.
have to make sure your insulation guys realize they have to insulate behind the drywall and insulate, you know, around the ceiling cassette, et cetera.
Yeah. There are always little nuances. You have to make sure your insulation company isn't putting rock wool. Say you've got a 2x6 wall. They're not just putting their 5.5 inch rock wool over that line because it won't compress enough for your drywall board to compress. And your drywall, though it will screw on in the moment, will eventually pop the screws as that dense insulation material starts to push back. So you have to make sure they cut around the line sets that are in the walls. But that's a good point because you can put these in remodels where you don't have to open up your walls at all, and you just core a little 3 inch hole from the outside to the inside, and you run your line set through that hole. And on the exterior of a wall, you have a cap that goes over it and hides the ugliness of the line set. On new construction, your line sets are able to run right inside your rough framing, and you don't really see anything until the line exits the wall. So it's a bit cleaner in new construction. But perception is in the eye of the beholder. Beauty's in the eye of the beholder. Like some people think, you know, that looks cool and they're doing a good thing and they're moving away from a fossil fuel heating and air conditioning system, and they don't mind seeing that. But these systems are made to work with everybody. Moving into our whole house ventilation, I've actually never installed a whole house fan in a project in my entire life. I don't. I know it's a really common thing to do here, and it's a fallback option for ventilation, but I couldn't even tell you how to do it. So all I've ever installed is some form of whole house balanced ventilation, where I'm not relying on uh, I'm going to say poorly built home, with the caveat that I know how difficult it is to build a home. Even in the best of situations, building a home is a really trying process for the people in the field. So I'd like to think, I would like to think, and I do like to think that we're all trying to do the best we can with what we have in the field. But um, A whole house ventilation system with just one fan is relying on a home being poorly built and being leaky because it needs to get its source of air from somewhere to exhaust throughout the house. So it's usually pulling from, you got a whole house fan in your second story at the top of a stairwell. It's pulling air all the way from down in your crawl space through your floors and out that whole house fan. So we don't install whole house fans, but we do use whole house balanced ventilation systems, and we tend to use a lot of these Lunos fans. Um, I think there are a couple others on the market, but builders like to use what we're familiar with, and learning new things on the fly just adds another step in our day. So I've been using these for a long time. I know where to get them. I get them efficiently. We get them efficiently. I know a few other people are starting to use them around here. It's great. These things are like on the checkout shelves at the hardware stores in Europe. Like everybody just puts these in their homes. So um, it's basically, think of it as about the size of a coffee can, and there's two of them. And you have one on one wall and one on the other wall. They get wired together with thermostat wire. It's just a little 2 amp fan. So they use hardly any electricity at all. And they talk to each other. And so one fan is pulling air in from the outside through a filter and bringing it into the house. And the other fan is simultaneously pulling air out of the house and pushing it outside. And then every minute and 30 seconds or minute, 2 minutes, I can't remember the exact number, they switch and they talk to each other. You can actually watch it if you get up close to it, and the fans will slow down and then they reverse direction. And the other one pulls air in through its filter into the house, and then the other one is pulling that air out. So you constantly got fresh filtered air moving through the homes. Um, these are about $1,000 for a pair, $1,100 I think for a pair, and you could put one pair in an ADU and get your balanced ventilation, technically with heat recovery as well, although we don't often calc the heat recovery from these systems because it's pretty small. Are you getting filtered, balanced ventilation into your home? So your houses are always smelling clean. Um, we have a house that we built on Studio Drive a few years ago that's often unoccupied for many months at a time. It's a second or third home. And I'll go over and check on it after nobody being there for 2 or 3 months. And the second you open the door, I mean, it smells like daisies inside. And it's, an old beach house that's been remodeled. It shouldn't smell as nice as it does, but because we've always got fresh air moving through that house, it's kind of glorious actually. They gave it to my parents to stay in for a week when my parents came to visit, which says a lot about those clients. Um, and my parents couldn't believe that they didn't have like the low tide smell of the East Coast wafting through the house all day. They absolutely love being in the house. Anyway, here's a couple quick photos of them installed. So this is a small ADU project. In a perfect world, we would probably have these further apart, but we didn't have a perfect world, so we did the best we could. So these two fans are actually working in tandem, and one of those is pulling air. This is a primary bedroom, and we often don't put just one pair in one bedroom, but we did as a request for this client. So one pair, this one might be pulling air in, and this one's pulling air out, and then they switch. This one pulls air in, and that one pulls air out. And you can tell, um, people have toured this, and anybody in here is welcome to come tour it again. But you can tell the moment you open the door in this house that it's got some kind of filtered air ventilation system working, because it smells so clean and fresh the moment you open the door, even after it's been closed for a while. Those are our ductless whole house ventilation systems. There are ducted systems as well. Zender is kind of a common one, and I put this middle photo is a Zender box next to my old tool belt, just to give you a size of the scale. Not real difficult to install. One person can lift that box up fairly easily, and it comes with a metal bracket, kind of like a French cleat, and it just kind of hangs on the French cleat, and you run duct work off the two top sides of that. Two of the ducts will go to the outside, and the rest of them run through the house through these smaller 3-inch tubes that you see on the left and right photos. So that's just one other way to get a filtered filtered fresh air with heat recovery system into your house. It depends on the assemblies that you're putting together. If you're designing a new home and you're going to use truss systems, whether that's floors and roofs, you have room to you're hopefully designing in your trusses room to run ductwork, which makes running ductwork easy. In a lot of homes around here where it's a smaller renovation or it's a much larger renovation, we're doing a 3,400 square foot renovation right now. And even with the renovation, it never gave us an opportunity to create a chase or to run ductwork. So we've used a ductless system in a much larger home. But if you're an architect and designing from the get-go and you have the opportunity to use trusses, you can create the room to run this kind of ducting throughout the house. Now we are going to move to the nuts and bolts of some of the appliances that we're putting in our projects, and Jennifer is going to take over the next few slides from here.
Okay, thanks, Mike. Oh, I do want to say one thing on that, those fans that bring in the fresh air, and even if you use an exhaust-only ventilation system, which we don't really recommend once you get the house super tight, you want balanced ventilation, so supply fan, exhaust fan, or like Mike was saying, the systems that work together. You can turn them off, because if there is poor outdoor air quality, like wildfire, they don't just keep running and bring bad air in. You turn them off and just use the air you have inside your house. But when the house is really tight, then it's also not leaking smoky air into your house, which is another added benefit that we start to see more and more after hearing more about people's experiences in like passive house or really tight homes with wildfire and just poor smoke air days. Okay, I see that there's a question, but it's also my time to talk, so I won't be able to get to that question in the chat right now. I'm going to address the heat pump water heaters, and then I'll come back to that question. Okay, with integrated heat pump water heaters, for those of you who are not familiar with them, the compressor, the heat pump part, is on top of a water tank. So these units are taller than a standard storage water tank because you've got the compressor, the heat pump on the top. And what that heat pump does is it pulls hot air, or warm air. It can actually be cool air, but there's still heat even in that cool air. And it extracts the heat out of the air and puts that heat through a heat exchanger into the water. And then what the blower motor does is it just blows that air out of the compressor. And now that air is much colder because it's pulled the heat out of the incoming air. And these units are so efficient, they're able to heat that water up to temperature that's appropriate for your domestic hot water needs. The big thing about these, one of the main things to keep in mind is that because they're relying on the heat in the air, some of the units need quite a bit of volume of air to pull from. So the older models, the rule of thumb was 1,000 cubic feet of volume. Then it was dropped down to 700 cubic feet of volume. And now with some of the newer models, they only need like 450 cubic feet of volume. And if you don't have quite the air volume you need, like you would if you install it in a garage or a really large utility room, you can add duct kits to it to pull air from exterior or other places around the home, or you can have communicate with the rest of the house through louvered openings. And then you're going to get a copy of the slide deck, so you'll have these kind of things to keep in mind and you can duct them or you can do non-ducted. And then there's a few things like, again, you could call this out as an architect on your drawings just for a better install, which, for example, is to use either PEX or flexible lines from the hot, cold piping, which I put the blue arrows to. It makes the installation easier, and it keeps the compressor vibration from vibrating into the structure of the house. And to keep in mind, the compressor itself, when that fan's blowing, some of them are around 50 decibels. So it's like a refrigerator, but a lot of folks don't want to hear that at night. So keep that in mind when you look for the location for your appliance. But if you use flexible line or a PEX line, that'll help reduce the vibration. But I gotta tell you from this photo, it's really hard to insulate the flexible line. And so technically the first 5 feet of your hot water line and your cold water line is supposed to be insulated. And keep that in mind. If you go with the flex line, they should be out there with the tape to hold it in place. And then two of the common issues to watch out for heat pump water heaters that I see when I'm out in the field. And this is, make a note, the architects, I think, put this in your drawings, but also if we had for the builders on the call, it's just remember when you're looking at your own project that your condensate line, because this is a heat pump, it's the air conditioner essentially, there is condensation, and that condensate has to drain to somewhere. So this is an example of where that just wasn't thought through. So the condensate drain line is like going to nowhere. It needs to go to a drain. It could go to the same place your washer drains. It could be a floor drain. So don't forget about that. And then the other is all of the units have a washable filter to help protect the little fins in the coil in the compressor on the top of the unit. And some of these filters pull up and some of them slide out, but you want to review that with your plumber and your electrician. Because like in this case, the whole, the installation looked really clean, but then we tried to pull the washable filter up and it's like, oh no, sorry, the electrical conduit was too tight over the top. So the electrician had to come back out and lengthen that conduit so we could get the filter out. Okay, the next picture just shows an example of what that looks like. And these pictures, these diagrams, I took straight from the manufacturer's installation diagrams. And in every case, they're reminding folks that you need that 6-inch minimum clearance to be able to pull the filter out, whether it's from piping or ducted system. And then this is also just kind of goes back to client expectations, owner maintenance. A lot of the builders don't know that there's a filter that needs to be cleaned every so often. And then, gosh, who knows if then the homeowners get the message that there's a filter that needs to be cleaned every so often. So I like to just alert everyone that, is on our trainings to not forget about that.
And so these are two examples of installs we've done where we have a unit inside a garage, mid installation on the left there. That's an A.O. Smith. I believe it's an 85-gallon tank. Real simple installation inside a garage. A benefit of heat pumps is that they're exhausting cool air, not cold air, but cool air. So in a house on the Central Coast that has an unconditioned garage, which a lot of people ask for, save a few bucks on the project, you're actually kind of putting air conditioning into that garage. So as you're using your system and getting hot water for the house, it's exhausting cooler air into the garage space, which means your unconditioned garage, which probably doesn't have an insulated roof and pushes 90 degrees just from radiation, actually will stay cooler if you've got this system operating in your garage. And then the middle photo and the photo on the right are we build louvered, uh, not a shed, but basically louvered closets, exterior closets. Um, this it might look fancy, but it's not even fancy. It's like a bunch of studs and some 1x6 rough sawn redwood that we attach to the framing. Uh, we've also put these in, like, somebody that we worked for had a old, like, metal high school locker system with louvers, and, you know, put that on the it wasn't actually a high school locker, it was a bigger utility locker, but just a metal locker, and, but it had a big louvered door on it, so we, put their system inside their house, with a big louvered door. So lots of different ways to tackle the task at hand if you're gonna whether you're doing it inside or outside.
Oh, before you go on, I just want to point out, Mike, that for the heat pump water heaters, they're becoming so common now. And we're expecting, I mean, we, like California Energy Commission, expecting a lot more of these to be installed. Just kind of heads up, in the 2025 energy code coming up, there's more explicit mandatory requirements on that ventilation and the condensate and all of that, because that's maybe a pain point, to make sure that the units get plenty of outside air or plenty of volume of air in the garage or house, that they can extract the heat from it efficiently. So just be on the lookout for that, especially with our other trainings coming up. Um, we'll be addressing the code changes.
Um, so, like at the beginning, we said we're assuming everyone is part of a zero energy home is moving off of fossil fuels, which we've done one fossil fuel project. It was a remodel in the last 7 years, I think, and we kind of um, drew the line in the sand and said we wouldn't do it again. And actually, the only reason that one ended up having fossil fuels was because it was peak COVID and we couldn't get the induction stove system that we needed, and the house already had gas, so we just kept it. But we're not putting any gas appliances in any of our projects, and um, so we're removing fossil fuels, reducing the loads, and then we're going to offset the loads that we're asking for with PV panels as we come to the end of this workshop, actually. So these are two examples of all electric kitchens. Um, I worry a lot about money. I worry a lot about economics. Like, you don't want to be the builder who says, "Well, we're building." I even hate the word green, but we're building green homes or more efficient homes or passive house homes, where passive house in Europe is a lot more expensive because you're building walls that are 13 inches thick. But a passive house, low energy home in California, you can use the same construction assemblies. So I'm always looking for ways to keep our projects down, unless clients give us the green light to, flex our muscles a little bit and get some design muscle thrown in, which I think all architects are. You're always trying to find the client who lets you, you know, do your thing a little bit more. But the photo on the left is that's an ADU, so that's going to be a rental for 5 years, and then the father and the daughter are going to move into this rental. So that's an $11,000 all-in kitchen, including appliances, so cabinets, fixtures, um, all in. That kitchen cost 11 grand. Not a very big kitchen. And then the photo on the right is a recent remodel that we did. I think both of the owners of these projects might be in this workshop. So if they are, they can chime in. But the one on the right is, a little more design friendly based, design focused project. But that is also an induction cooktop. And we shared the story of this on our socials, I think a week or two ago. That's a third generation stove. that's been moved all around the country actually by this family. And we found a company, it's actually called Apple Stoves up in San Jose, no relation to the tech company, that can convert old wood burning coal and gas stoves to induction. So we wanted to keep this stove in the family, and we were able to find a company that converted the top to an induction cooktop. The oven is now just bread storage, and there's a separate oven in the island. But just two examples of the wide spectrum that you can run building an all electric kitchen for any of your projects. We're using heat pump and condensing dryers in all of our projects as well. Uh, I think if you talk to any builder, they'll moan and groan when you mention venting um, dryers, because it's always one of the things that gets done at the end of a project. There's all kinds of little contraptions that claim to make it easier, but you always end up with like some young kid hanging by his ankles down the backside of the dryer and trying to hook the dryer vent up, and get a zip tie around it as it attaches to the back of the dryer vent. So we're trying to push people towards ventless systems. There are high end ones. Fisher Paykel makes a nice high end one, and LG makes a budget system. You know, you're not buying washers and dryers off Marketplace or Craigslist, so you're buying new stuff with warranties, so they're not super cheap. But um, there are little nuances to any of these things. So they do have condensers on them, and you do have to remember to clean the condenser every now and again. There's usually a notification light on the system that tells you, and it's really accessible. This photo is one of our projects. So we've left a little homeowner's manual with the clients that instructs them how to do that, which they just passed on to their housekeeping company, and they take care of that. And then these are the LG system that we've recently installed in a budget-friendly ADU. So just a note that there are little nuances of taking care of them. This is an
Oh, can
all-in-one.
I add a quick thing on that one? Yeah,
Yeah,
like the LG, like this one, for example, has you can either clean that condenser manually, or it has a automatic cleaning mode you can set up, but then you just have to know it takes about an hour for it. So I think that's kind of cool. So when you're looking at purchasing these, it kind of depends on your personality. If you think you'll actually remember to clean them, or go ahead and get the ones with the auto clean mode.
which is good for this one because this is a college rental. So they're going to be three college goofballs living in there, you know, probably not remembering to do any of that stuff. So perfect for that system. And this is the LG all-in-one washer and dryer. I actually almost bought this one for my own house over the weekend, so I probably will pick it up next weekend. But we've recently installed this one in a project as well, and we actually just tucked it into a corner in a bathroom. Doesn't take up too much space. So people think these are cool because you throw the clothes in, and 3 hours later they're washed and dried all at once. No switching loads or anything like that. So that was a little rundown of the appliances. Now we're just about to wrap up, and Jennifer's going to walk us through offsetting with PVs and batteries.
Okay, so I mean, kind of big picture on this. When we talk about zero net energy, the whole idea really was that at the end of a year, you would have sent as much energy to the grid through your PV system as your house would need at the end of a year to run it. And it's usually we're talking zero net energy, that would imply electricity, and the whole house would be electric, for example. Oh, really quick, Mike, about how expensive was that all-in-one dryer washer set? Isn't it like
Two,
1,500, 2,000,
uh,
somewhere in there?
I almost bought it for 1,600 on sale at Home Depot.
Yeah.
Yeah.
Okay. Great. Thanks. I saw that was a quick question. There's a bigger question I'll answer here after that about mini splits and all that. So, but what kind of comes into play when you're doing PV and battery is that if you can afford to buy that system outright, there's going to be, you're essentially buying all of the energy you need basically for 20 years at a slot, 20 years at a time. So this graph is to show you, okay, the first year you're kind of in the hole because you're paying back the system. Same second year, third year, fourth year. About year 7, year 8, with the current rates of electricity, you're going to be looking at breaking even, and you'll be doing better than break even for a little bit, but then the chart dies back down and then it bumps up again. And what that's about is the time you're either buying a new, maybe an inverter, the warranty, 10-year warranty wore out, or your 10-year warranty on your battery is out, and you may need to make another investment. And then you start to get cash flow positive again. So that's kind of a client expectation we want to put up there up front, that halfway through the life of the system, you may need to put a little more money into it. And that's kind of the way it goes. Okay, next slide. So when we're talking to our clients about zero net energy, we often are looking at, for new construction, explaining here's how many PV panels you need on your home to meet the energy code. And then here's some more panels you can add to reach that zero net energy mark. And sometimes that number is between 40 or 60% more than code. So it's lifestyle dependent. It's a little difficult to predict for a new home. And then you're going to add more PVs if they drive an electric vehicle and expect to charge it at home, for example. But if you add a storage system, it can add resiliency for sure. And it also can reduce that PV system size. So we try to look at that in terms of that balancing point on new construction. Existing construction, you get the advantage of looking at people's actual utility bills and sizing the system to really meet their needs so they have the best payback. Okay. And part of this whole thing that we've been talking about, why we're able to do this, is because now a lot of our appliances and heating and cooling systems were fossil fuel based. We now have high efficiency heat pump and induction, like cooking, induction options. So now we easily can do our heating and cooling, our hot water, our cooking, and our laundry, all with inverter heat pump technology. Even the new refrigerators now are having inverter heat pumps that are more energy efficient. So that makes this possible. Still, there is some management of client expectations and what it means for zero net energy, and what that means practically speaking. And this is a chart from my house in October in 2024. And what this shows is that many of the days, and it didn't quite do the rest of October, because you can see the 31 there, 30, 31. Like, yes, I used more energy on that day than it shows. But the point is, for most of that month, I had the use my house and I depended on the battery. And sometimes I was sending energy to the grid, because in October, we had more solar energy being produced than my house really needed, because I wasn't running heating and I wasn't running cooling. And October's a great shoulder month where the temperatures are really comfortable. So I'm overproducing. And then, next slide. And then we're going to have seasons where it's going to be, winter, where I'm pulling from the grid. And so that means you still get a utility bill. The other client expectation is some folks don't realize how much space all the equipment takes when you move to solar and battery. So you'll still have your electric panel. The new code is 225 amp main electric panel. They'll need a gateway, isolation equipment. So each brand of battery has its own type of gateway, and then you'll typically need your sub panel with your backup loads. So that's a lot of space. And then you're going to need space for the inverters from your PV system, your house disconnect, and then the battery system itself. So quite a bit of room. And this is an example of a local project here in San Luis Obispo showing, giving you an idea of how much space is needed for their in-phase batteries and their disconnect and their controller. And it includes EV charging with it also. And it used to be a lot more common to install these systems inside the garages to protect them from weather. You still can do that. Fire department prefers them outside. So you do have to work with the manufacturer, but both examples, the Tesla battery type and Enphase and a lot of the others are going to a battery chemistry that is not prone to combustion like the first, the first generation of batteries. And then the other part of that client expectation and just understanding what's happened with your quote unquote zero net energy home is some days with a battery system, your day for the 24-hour period, like the chart on the left, this is from my own house. I only depended on the grid 1% of the time, but then the very next day it was cloudy and I was having to pull 18% of the energy I used for that day from the grid. And I only charged my car just a little bit because I needed a little bit of charge. And so only 1% of that energy use went to my car that day. But on the sunny day, I try and get my car charged up and take full advantage of all the energy I'm producing and get my battery stored up. So that's part of that resiliency. And kind of now when we look at zero net energy with battery, it's both and how those things work together. So kind of the takeaway with managing your client expectations when they're looking at solar and batteries is some days, even with the solar and battery storage, your household's going to use grid energy. So you're going to have an electric bill. And then part of the savings, if your client has an electric vehicle, a lot of times that is where they'll see savings that they wouldn't otherwise have seen on their utility bills. It's just that if they were driving an electric vehicle or had planned on using superchargers, for example, they're now going to get a savings with their PV system if they can charge it at home and charge it on solar and set it up to charge on solar. And in my case, I don't drive that much, but I still save over $100 a month just with, and I have no gasoline that I have to pay for. And the maintenance is lower on my electric car. So that's kind of helps with that. And then I'm going to let Mike just kind of do that wrap up. And then we have at least one question I want to address in the chat, and feel free to put some questions in the chat.
This is our barbecue sauce slide. If anybody's a Ted Lasso fan, this is our little callback to the beginning. So hopefully we wrapped it up and we hit the stuff we were supposed to. But we spent the first 3/4 of this talking about how the builders in the field and how you can direct your builders in the field and talk to them about the physical things, the tangible things they're doing are able to reduce the energy loads of the home. And it really does come down to what we do in the field and the details that we put together in the field. It was just my perspective on things. I've been doing it a long time. I've made a lot of mistakes. I've found systems that work for me. If you ask 100 builders how they do things, you'll probably get 99 different answers, and 99 different materials, and we'll all have an opinion. Um, One thing most builders between the ages of 30 and 50 love to do is get asked a question about their job and talk ad nauseum about the thing that they do for a living. So these are just the things that work for me, and they've worked for a long time, and they work for our clients, and all of our clients are happy. Say 99% of them. Um, can't win them all, but we try. So we've driven down the loads, and just by doing that, we're making the challenge of getting to a zero energy home smaller, and we're trying to give people ways that are easier methods to do it, common methods to do it, and hopefully fairly easily teachable ways to do it. That, like I showed you in that pie chart, we're talking about very low hanging fruit to make this happen. The slivers of the pie chart are so small that you can't even fit the percentage number in there because it just disappears. So this is not the big money stuff. You know, the big money stuff is spending 15 grand on a front door and 6 grand for the door handle. That's the big money stuff. So, all right. Thanks for coming to our TED Talk. I'm going to pass it over to Danica again, and she'll wrap up the 3C Ren stuff, and then we'll get to some questions.
Thank you, Jennifer and Mike. And thank you everyone for coming. If you have any Energy Code or Cog Green questions, we have a Code Coach program to answer those questions for you. And Jennifer here is actually one of our code coaches. Next slide, please. If you have any questions in receiving your AIA units, please reach out to Chloe at chloe.swick@ventura.org. We will be sending an email in the next couple of days, which will include the recording of this course, the slide deck, and a survey. We encourage you to fill out the survey to give us a better direction on what y'all are interested in. And we will soon be in the process of choosing courses for the next quarter. So if there's any topics that you are very interested in, please include that in the feedback as well. And we have a bunch of upcoming courses, such as a green building construction tour in Santa Barbara that will be in person, and the rest natural installation options, as well as our Energy Code implementation series featuring ADUs. And if you are interested in getting Passive House certified, we have a 5-day in-person Passive House trade person boot camp course in Ventura from September 29 to October 3rd, and also a certified Passive House designer / consultant cohort that is offered every quarter. You can sign up for these trainings and see more offered on our website at 3c-ren.org. And with that, I'm passing it back to Jennifer and Michael for any last minute questions.
Thanks, Danica. We have there was one question I answered partly in the chat, but the question was wondering about dealing with the condensate line off of those indoor mini split units and kind of where it goes and what we do with it. And I would say, generally speaking, what I have on the projects we've worked on that are additions and remodels, where you're installing the systems after the structure's been built, like Mike was saying, for those indoor units, you're going to make some kind of penetration through the envelope, through the wall. And if it's wall mount, it's directly behind that. If you're doing a ceiling, recessed ceiling units, or even concealed ducted units that are up in an attic, they're going to have your refrigerant line and a communication line and a condensate line. And those are going to have to be run out. And typically we run them out to an exterior wall and then down to the ground and to the condensing unit, and then they're covered. So that kind of takes, in a sense, that takes care of that. But on new construction, and especially if you're like the ceiling cassettes or wall mounted on an interior wall, if you end up really needing to use an interior wall, then we're looking at how do you gravity feed the condensate line into your sink drainage pipe or other acceptable way of taking that condensate into the drain system. And Mike, I want your take on that, but that was
we've
kind of my
done
longer answer of what I short
yeah
answer typed.
we've done both, and it just takes a little bit of thinking and some thought. It's just condensate, so it's just water. There's nothing in it. We generally try to get them to just drain directly outside, but we've tied a couple of remodels where because we like to centrally locate our heating and air conditioning units, even if it's a wall unit. And so we will tie that condensate line into a sink drain. And that's totally legal and up to code. And yeah, we've done both.
Right. And it's different when you hear about also with your heat pump water heaters, that condensate and condensate from your heating cooling system, the indoor units on those mini splits. It's the condensate that you get on the outside of a cold glass, a cold beverage. We'll just leave it at that. There's all kinds of beverages. But it really is just the moisture from the air that's condensed, as opposed to the condensate on fossil fuel appliances, because that is a different type of condensate. And yes, the plumbing code comes into play, and it is acidic, and there is issues with that. But these are non-fossil fuel. It's just absolutely the same moisture in the air that you're breathing. It's just that it's cold and it condenses. And that's the same way those ventless condensing dryers work, is they use a little bit of, with the heat pump style, a little bit of refrigerant to make a condensate kind of cycle, and it dries out the air. And so that condensate has to go somewhere, and either it's drained by gravity, or it goes into a holding tank that you have to empty if you're not able to connect it up to a drain line. But it's the same thing. So we're just creating dry air. It's gentler on your clothes. And
As
it's
a side note to those dryers, if you talk to people who use them, they'll kind of look at you and laugh about how comfortable their clothes are all the time now. You're not destroying your clothes, because effectively with a gas dryer, you're cooking, you're frying your clothes when you put them in there. With these heat pump dryers, the condensing dryers, you're pulling the water out slowly. So they take a little longer, but they take like the normal amount that we used to have, 6 or 7 years ago. It would take 45, 50 minutes, an hour to dry a load of laundry. Now we expect it to be done in 15, 20 minutes, but you're cooking that 15, 20 minutes at a high temperature. So these are much gentler on your clothes, so your clothes will last longer. And the people we know that are using them talk a lot about how comfy their clothes are now, which is, again, a
yeah,
byproduct.
right, it is. And another thing to keep in mind on those ventless units, you saw those installations, those projects were from projects Mike had built, and all of them, you notice that there was the ability for air to circulate around the units. So, okay, architects and builders too, there's a couple of things going on. One, it's like practical to have a little more space so that you can actually hold on to those units, pull them in and out, and deal with that. The other thing is having a little more space around them. It's actually part of that whole system also needing plenty of air and ventilation, because with all the heat pump technology, they're either depending on pulling the warmth in the case of heat pumps, and also dependent on pulling moisture out of the air and having plenty of air that is dry for your dryer. So you need communication with a larger space. So just keep that in mind. My nephew had the stacking Bosch units, and he was unable to get his clothes to dry. He was extremely frustrated. And my sister's in the trades. She called me and I talked to them about what's going on. I was like, oh, you cannot close the door, the closet door. They installed it in a closet. You cannot close the closet door and just walk away from it. So the fix was either you need a full louver door or you have to keep the door open for that small closet to do the drying. And then I pulled up the owner's manual for them on those units, and it clarified, Bosch gives examples of what that looks like. So just heads up if you're designing it. Like those pictures we showed you, that's what they should look like when they're installed. Because they do need a air circulation, because you get the humidity buildup and moisture temperature buildup in those closets.
Cool.
Okay, well, I think we're right at time, and I haven't seen any more questions in the chat, but if there's anything, one last one, we might have time.
We always throw it out there that if people are passing through town, you're welcome to stop by our projects. So we're pretty open to show stuff off to people. You want to see stuff in person.
Yeah, and with that, I want to be respectful of everyone's time.
Yeah.
And I'll hand it back to Danica. And thank you, everybody.
Thank you, everyone. Yeah, that should be. I don't see any questions on my end either. So yeah, thank you, everyone.
Great. Thanks all. See you again soon. Have a great week.